Sometimes students find the classification of matter actual questions on homework and assessments to be kind of challenging. So I've made this extra video exploring some of the ways that I might ask you to classify matter on an assessment so that you have an opportunity to walk through it with me before you have to do it on an assessment. It can be tempting to start with this video first rather than watching the two previous videos where we laid the foundation of how to do this and we explored the definitions of elements and compounds and how to figure out whether you're talking about that or the different types of mixtures. So please go back and watch those first before starting this video so they have a good foundation. Alright, so since this is pretty much just a straight example video, I'm going to put the examples up first, encourage you to stop the video, and then start it again once you've figured out what you think the answers are, and use my discussion as a way to check your understanding. So in this first example, you need to identify each of the following as a compound, an element, a homogeneous mixture, or a heterogeneous mixture. And I've got 1, 2, 3, 4, 5 questions there for you to read through. So take a moment, stop the video, read through those, decide what you think the answers are, and then start the video when you're ready to compare with what I've got. Okay, so in this first example, we have a non-uniform. Non-uniform. That's telling me that I'm not looking at all the same stuff. It's a white crystalline substance, but clearly there's visibly more than just white crystalline going on. So that gives me a hint that I'm looking at not a pure substance, and in fact that I'm probably looking at a mixture, I'm probably looking at a heterogeneous mixture. But let's keep reading to see if we get some more information. It tells me that part of this dissolves in water and part of it does not dissolve in water. So part of it has one physical property, it will dissolve in water, and the other part does not, verifying my initial suspicion that this was indeed a mixture. The non-uniformity of it is telling me it's a heterogeneous mixture. It can be tempting to take a shortcut here and not write heterogeneous mixture, but just write heterogeneous. I'll give you a forewarning on assessments. You need to write the whole phrase out, or you'll get it wrong, which would really stink. In our second question, we have a yellow solid which completely melts. Okay, that's giving me some important information at 45 degrees Celsius. So a single melting point, we just have a yellow solid. So I know this cannot be a heterogeneous mixture, and because it completely melted, it only has one melting point, I know that it's not either type of mixture at all. And so I'm trying to decide at this point, is it a compound or is it an element? I read further and see that it decomposes upon further heating. Well, we know that compounds decompose when they're heated, but elements cannot. So this must be a compound. In the next example, I have a colorless gas, okay, just one phase, so it's not a heterogeneous mixture, only part of which, okay, part of it's going to do something, reacts with hot iron. So part of it has this chemical property, the rest of it does not. That's telling me it's not a pure substance, because if it was a pure substance, if it was an element or a compound, all of it would react with hot iron or all of it would not react with hot iron. So this must be a homogeneous mixture. Next one I have here is air. Well, if you think about air, you see one thing. And if you think back to maybe some previous science classes, maybe in high school or middle school, somebody probably mentioned that air had nitrogen and oxygen and some other things in it. It's got water, sometimes it's got pollution. Generally, though, when we look at air, we're just looking at one phase. And because that's the case, we know it's not a heterogeneous mixture. It's one phase, but we know there's multiple things present, and they're separate from one another. We say there's nitrogen and oxygen present, so that's two separate types of elements. So we know that air is a homogeneous mixture. Last, we have a substance which reacts with cobalt to make a cobalt-nitrogen compound. So pretty much this sentence is saying I have some question mark thing which reacts with cobalt, and I end up with cobalt and nitrogen making some kind of compound together. Well, that suggests to me that over here I had nitrogen. We know that in order for this to be a homogeneous mixture or a heterogeneous mixture or even a compound, I have to have had more than one type of element. I don't, so therefore this must be an element. Okay, I hope you got all of those right. Or if you didn't, that's okay. You can go back and do some more practice, or maybe send me an email and ask for some examples or more problems to work through. Here's our second example. We have a red and black speckled solid, which is substance A, that is ground up, and the red powder, which is substance B, is separated from the black powder by using a magnet to collect the black powder, which is substance C. Whew, a lot of substances. The red powder is heated and observed to melt at 110 degrees Celsius and also at 500 degrees Celsius. The black powder is heated further and no further changes are observed. Classify A, B, and C as elements, compounds, homogeneous mixtures, or heterogeneous mixtures. Okay, let's look at what information we have. For substance A, we know that it's a red and black speckled solid. So I can see there are red things in there and there are black things in there, which tells me I'm looking at two separate things. So A must be a heterogeneous mixture. To back that up, when we grind A up, I can separate the black stuff from the red stuff by using a magnet. That's a physical property that I'm using to separate one thing from the other. So they're keeping their own individual properties. Again, a characteristic of a mixture. All right, let's check out substance B. What do we know about it? Well, we know it is heated and observed to melt at 110 degrees Celsius and also at 500 degrees Celsius. So I see two separate melting points. That means I have a mixture again here. It was just a red powder, so I only saw one phase present, so this is a homogeneous mixture. Those two melting points were a big clue to the fact that it was actually a mixture. If it was a pure substance, I only would have seen one melting point. All right, let's talk about C. The black powder is heated further and no further changes are observed. So we heat it up and nothing really happens beyond what we have. Now in theory this should melt and eventually form a gas, but it doesn't mention that here. It just says no further changes are observed, which means that it didn't decompose. So this problem is a good example because we're having to look and think critically about what's not happening. Well, what's not happening is this is both not showing multiple melting points or boiling points or whatever, and it's also not undergoing decomposition. So that means I can't have a mixture, because I didn't have multiple melting points or boiling points, and then it can't be a compound, because if it was a compound, it would have undergone some further changes, and eventually it would have decomposed, because we would have heated it hot enough. So that leaves me with only an element for my last choice. Now just a tip, when you're looking at these types of problems on an assessment, sometimes students think, oh, I can only use element for one time and compound one time and homogeneous mixture or heterogeneous mixture one time. Don't think that. You may find that you're using elements multiple times or compounds multiple times, etc. In this case, I didn't use compounds at all, and the other ones I used once. But don't think that that means that I couldn't have had an example where, say, two of the things were heterogeneous mixtures.